This Module 1 homework problem, they give you a bunch of information about an unknown liquid. They tell you that we measure out a specific volume of the liquid, about 0.558 liters, and we know the mass of that is 441 grams. They would like you to find the density of that and then compare that with the list of the liquids over here to confirm the identity of what we're working with. So typically, right, density is mass over volume. Typically, we find density in units of grams per milliliter. And we have liters here. So we can certainly convert liters to milliliters, which we need to do. So got 0.558 liters. We know in 1 liter, there's 1,000 milliliters. So we have 558 milliliters of this liquid. And this is where some of you were kind of stuck as to what to do next because you saw density over here and they had units of cubic centimeters. And I shared this in one of the classes, but 1 milliliter is equal to 1 cubic centimeter. So we can simply replace milliliters and say, okay, I've got 558 milliliters. I also have 558 cubic centimeters of this liquid. Now we can find our density because density is mass over volume. So I've got a mass of 441 grams and I have a volume of 558 cubic centimeters. I divide those two and I get 0.0790 grams per cubic centimeter. I would say 3 significant figures because, again, addition or a division and multiplication. The number with the fewest significant figures limits what we can report. 3 sig figs here, 3 sig figs here. We should have 3 significant figures in our final answer. So I'd put 0.790 down here. Then we can go and look at the list to see, right, this looks pretty close to acetone. So I would say, yes, I can identify what that liquid is. And I could say, I'm pretty sure it's acetone based on that density. So your volume might be a little bit different, your mass will be a little bit different, but the steps would be the same. We were going to need to convert that volume into milliliters and then know that 1 milliliter is equal to 1 cubic centimeter so that we can go over the units that we're seeing over here in this data table. Then we can find our density, density being mass over volume, just making sure that we've got the correct units for that calculation. Hopefully this number is very close to something that's listed here. If it is not, if it's not within 0.01 or 0.02 of one of these numbers listed, I would say we can't determine the identity of what's listed over here. So hopefully that helps with this calculation.